Hello, so today we are going to do the first problem from January daily challenge. So we get two strings, parent and a string s. So parent is like this and the string s is like this. And what we want is to find if s follows the same pattern as here, right? And what do they mean by follow? Basically, by follow, they means there is a match where if we do a bijection between every letter of pattern and a word of s, then we would then the bijection will hold across the string. So what does that mean? So basically here, it's at the start we have a match is corresponds to dog, right? So once we do it, then every appearance of a here has to correspond to an appearance of dog in s. And similar thing, b now is cat, right? And now if we get b again, s the corresponding s word has to be cat, and that's the case. So that's good so far. A, we already saw a, and a should always be dog. So and that's the case. So far everything was correct. So we return true. For this, however, first we associate a with dog. So if it's not there already, we can associate it to any other word. There is no problem there. But if it's there, it has to match, because once we associate, it will always be mapped to the same word, right? So if we map b to cat, now we get b again, it's mapped to cat, so that's valid so far. But then when we get a is already matched to dog. But here it has fish, so this is false because it's no longer the same match. So we return false, right? Okay, so that's the idea. Now if we take a look at this example again, we first associate a with dog because we don't have a yet. But then when we look at this a and this this mapping here, it's cat, it's no longer that dog here, so we return false. It doesn't work, right? So that's roughly the idea here. Now how do we implement it? Well, it definitely seemed straightforward. Like what I was doing when I was doing the examples is just sort of creating a map association. So we have, for example, parent is this, and then we have s was dog, cat, dog, right? So what we can do is definitely have a map, let's call it from parent to words. So we'll end up splitting these to be words just so that we can access them easier. So it would be, so we'll split by space and we'll get these words here, right? So first we get to a, right? Here. So our I is at position 0, right? And so we don't have it in our map here. And so if we don't have it, then we can just associate it and move on, right? So we say a now maps to dog and move. Okay, so now we check, is b already in our map? No, it's not. So we can just do the mapping. So we map b to cat. And then we advance. Now b is already in our map. So we check if this is the same as what we have already mapped. If it is, which is the case, we can continue. But let's say if this was fish, then we can already return false, right? So as soon as we find a key from parent, where the value is not the same as the one it's associated to when we are looking, then we return false, right? And so we move on here. So here, because it's cat, it's good, so we move on. Now a maps to dog, the value is equal to dog, so we are good. We continue. Now we end and we finish it traversing, and we didn't find an invalid value, so we return true, right? But let's say here we had maybe, I don't know, like snake or something, right? So if we check here, it doesn't match dog, right? It's different, so we return false, right? So that's what we can do in this case. So we definitely know that we need this map. Okay, but is that enough, you may say, right? For example, let's say let's take a look at the examples we have here. Let's do it with one map, and then there is one example where it will fail. It's not enough to just have this map. We'll need a map for words to parent to be able to detect some other special use cases. But first, let's do it with this, and I will show you exactly why it doesn't work. Why it's not enough at least. So what do we need? We need a parent to word map. And so this would be a map like this. And then we need to go through the range of the length of pattern, right? And then what we said is we want to split, right? So that we can get a list of words, right? And now we'll just check if this character pattern I is not in our parent word map, so it's a new one, right? Then we want to attach it, right? But let's say first if it's in. So if it's in it, and the parent word in that position is different, right? So for parent I is different than the word I. So that would be the case where this here snake. So we'll check what is the, so we'll check if A is in parent word, it would be in, right? And then we'll check parent word for A is equal to dog, which is different than snake. So in that case, we know we want to return false, right? But otherwise, we want to, it means it's either it's not there or it was equal, right? If it's equal, we are good. We can still add it. It would be the same thing. But if it's not there, we want to add it, right? So we add parent at I. We assign it words at I. Okay? Now, if we go through all of them and we didn't find an invalid case, we want to return true. Okay? So let's see if this is enough. Let's submit. Okay, so here's the case where it doesn't work. So let's say we have this as our pattern. So let's just remove this, and this is our word, right? So it's just dog, dog. Okay, so what will happen here is that we will first come to this A, and would be here. So it's not there, so we just attach it, right? So we just say dog, and then we move. But now, you see the problem now, B and dog, B is not there, so we'll just say B also is attached to dog in our example here. But this is not right? Because the mapping is no longer unique, and that's not something that we want to do. So for that, how do we fix it? Well, we could just here do the mapping from words to dog. So when we do the first matching, right, like this, we want to also say dog maps to A. Now, if we advance and we say, okay, B is not in this one, before adding it, we want to check, does dog already have a mapping? Yes, it does. So we want to check now, does this mapping correspond to the letter that we have here? But it doesn't, so we know that we don't have a valid one, so we return false immediately, right? So that's the case where we want to use an extra map here. Okay, and so let's define that. So word to pattern. Okay, and so this would be a map like this. And we want to do a similar check. So we want to check if the word, like we said, check it here, if dog is in the word to pattern map. So we want to check if it's in word to pattern map, and it doesn't match. So if whatever is mapped to that dog, which is B, is different, which is A, is different than the current one, then we have it's false. We want to return false. So if word to pattern of words I is different than pattern of I, so sort of the reverse, right? Just inversing the lookup here, then we want to return false. And then we want to set it as well each time, like I did here. Okay, so this would be word to pattern, but this would be for word, and this would be pattern. Okay, and that should work for this use case that we just saw. So let's add our use case that we have here, which is AB, like this, but dog. And that is case passes, alright? Okay, so let's submit. Okay, so we still have a problem with this one here. Yep, so let's see why is this a problem here. So you can see the number of characters we have is just 3, but here we have 4 words. But that will still pass here because the mapping is working properly, right? So we also need to check for the length, right? Because here it says a full match, right? So what we want to do here is just check if the length of the pattern is different than the number of words, then we want to return false. Okay, and that should work for that use case. Let's submit, and that passes test cases, right? So in terms of time complexity, we are using one loop that is of the length of pattern. So let's call the length of pattern n. That's also the same as the number of words. Now, in terms of space, we are using these 2 maps where each can be oven, right, up to the number of characters and the number of words. So both oven time and oven space here. Yeah, I think there may be a way where you could get around with just using one map and just checking the values here. You could try that, but yeah, I think this is good enough. Yeah. So please like and subscribe, and see you on the next one. Bye.